Welcome to the Science for the Public lecture series. Science for the Public is an organization committed to bringing science information and issues to the general public. Visit our website for our program listings and blog. Good evening. I'm Yvonne Stapp for Science for the Public, and I welcome you to Contemporary Science, Issues, and Innovations. Tonight's guest is Dr. Brian Helmuth of Northeastern University, where he has a dual appointment as Professor of Marine and Environmental Sciences and also as a professor in the School of Public Policy and Urban Affairs. Dr. Helmuth received his PhD from the University of Washington in 1997. He held a postdoc at Stanford University afterward, and in 1999 he joined the faculty of the University of South Carolina. He became a full professor there before moving to Northeastern University in Massachusetts in 2013. In addition to his dual academic appointment at Northeastern, he's the director of the Sustainability Science and Policy Initiative there. He also serves National Climate Assessment. The focus of Dr. Helmuth's research is on the effects of climate change on seacoast marine ecology. This research, as we're going to learn tonight, is a key component of climate studies. Dr. Helmuth has developed innovative tools and mathematical models that set a standard for monitoring temperature changes in seacoast organisms, and his work has produced some unexpected and important discoveries in ecology and climate science. In addition to his research leadership, Dr. Helmuth has demonstrated a long and deep commitment to science education. For example, science teachers are regularly included in his projects. For his scientific work and his work with public officials and his efforts in science education, Dr. Helmuth has received a number of awards, and some include being named a Google Science Communications Fellow in 2011 for climate change, a Ray Lankester Fellow in the Marine Biology Laboratory in Plymouth, England, and an Explorers Club National Fellow. It is a very great honor to welcome Dr. Brian Helmuth. Welcome.
Thank you.
And I'll start off with asking you, what is a coastal ecosystem? What is it?
There are so many, and in a lot of cases we drive right by them here and don't even notice them. So in this region we're talking about everything from rocky coast to salt marshes to the subtidal systems that support fish with kelp beds. And moving farther away, we're talking about mangrove environments, coral reef environments. There's a huge diversity of coastal environments around the world, and in many cases their productivity is equivalent to that of rainforest. So they're incredibly important.
So it's a
ecosystems.
seacoast rainforest.
Yeah, they're just so vital to human well-being in so many parts of the world.
What is it comprised of? Like, what's our local one, the one that you work with mainly, in, say, in Massachusetts? Does that include the microorganisms, the fish, the shellfish?
Absolutely.
What is it? Plants?
Absolutely everything. And so, so we think about whole ecosystems, and that's not just one part. So oftentimes it's the things that are more obvious, the things we really depend on, like lobsters and crabs and fish. But it's also, as exactly you're saying, it's the microorganisms, it's that entire functioning ecosystem and how they interact with one another that drives their stability and what they do for human society.
I see. And why is this system so important to the health of the world, of the planet?
Yeah, coastal ecosystems are really kind of on the front line of how humans interact with their natural environment. I mean, just as an example, if you look at coastal counties in the U.S., it's about 18% of the land area, but it holds more than 50% of the population of the U.S. More than 20% of the people around the world depend on the oceans for their protein sources. These are also, as I said before, among the most productive environments. It's also where we support our fisheries. It's where things like nutrients get absorbed, where nutrients will run off from the environment. We may put them out there as sewage.
Right.
Something has to happen to those. This is where it gets processed.
Yeah.
On top of all this is where climate change is really having a big impact.
Yeah.
And probably a lot of people don't know, but here in New England, the Gulf of Maine is warming faster than 99% of the large bodies of water on Earth. So this is really ground zero. This is where all the human natural environmental interactions go on.
Why is that the Gulf of Maine? Why is that this
We're still
barometer?
learning. We're still learning that. I mean, one of the kind of misconceptions about climate change is we talk about these huge averages. We talk about average surface temperature, and that's really meaningful. If you look at now in the last ice age, it's a difference in average temperature of about 6 degrees. So if we're talking about an increase in 6 degrees, that's a really big difference. But there's a huge amount of variability over the surface of the Earth. So the poles are warming a lot faster than other places. This happens to be one of the areas that's warming really rapidly. The coast of China is another one. The Middle East is another one. So there are just these kind of hot spots that are really getting hammered even more than other places in the world.
Since you have a global reach in terms of your research and stuff, does this surprise you that why are these hot spots where it doesn't seem to make sense to us?
Yeah, this is where it gets really complex, and this is where it gets into the field of the physical modeling. And I'm a biologist, and so I rely on my physical modeling colleagues. But basically, we're moving heat around the globe. And whenever you have heat, it's taking up moisture. So places that are drier are getting drier, places that are wetter are getting wetter. Hurricanes are getting stronger because we're taking more moisture into the atmosphere, which feeds the fuel of hurricanes. And so really it's just that combination of moving heat around and how it interacts with water that drives a lot of the climate that we see.
That's scary because it sounds less predictable somehow. I mean, we know about the poles, but this hot spots on coastal regions seems strange, a little bit strange. Before we move on, you mentioned this problem that I'm sure most of us are not aware of the runoff from farms, all the chemical runoff, urban runoff from sewage and so forth. Guess where it goes first? The coast.
Right.
Can you give us any background on that? Just what's happening there?
Yeah, the old acronym used to be the solution to pollution is dilution, right? That would go out to the ocean, then it would just kind of magically go away. But it turns out that this stuff doesn't go away. I mean, it accumulates as sludge in the bottom. I mean, again, you've seen that here with Boston Harbor. Boston Harbor is so much better now than it was even a decade ago. And so it's agriculture, it's even emissions from cars. Nitrous oxide will go up as nitrogen, it'll end up in the ocean. And so all those microorganisms you're talking about, all the plants, all the animals that depend on them, are what's cycling these nutrients. And so as long as the ecosystem is functioning well enough and we're not getting a huge amount of nutrients flowing into the ocean, we're doing okay. But guess what? On top of climate change, which is changing precipitation patterns, we're getting these heavier rainfall events. So even if average rainfall isn't changing in some places, it's coming all at once, which all means it runs into the ocean, and we're paving everything. I was in South Carolina, as you said, and Charleston, South Carolina is starting to see salt water in its drinking water.
Like Florida.
Yeah, exactly, because there's no place for that water to be absorbed. It's all running off the pavement into the ocean, where it's carrying everything from that surface into the ocean with it.
In view of the fact that a lot of this is toxic, do you have any information about that, this impact?
Yeah, so there are toxins going into the water, and one of my colleagues at Northeastern, Loretta Fernandez, is looking at that. She's looking at how these accumulate in things like mussels and oysters. Some of them are not toxic per se, but there's just too much of it. There's too much nitrogen or there's too much phosphorus that goes into waters. And it causes things like algal blooms. If you've heard of the dead zones that happen a lot in the Gulf of Mexico, but now we're seeing them in other parts of the world as well. You get these nutrient runoffs that feed the phytoplankton, the tiny little plants in the water. They suck down the oxygen, they die, and then they decompose, which causes an oxygen drop. And so we literally start seeing these die-offs where there's no oxygen in the bottom of the ocean. the one in the Gulf of Mexico is now huge, and it's persistent, and we're seeing them other places in the world as well. And so it's no longer unique to that part.
And it doesn't revive anytime soon, apparently. It doesn't bounce right back.
No. Some of these,
apparently.
Some of these impacts are lasting for really a long time.
Right. Okay, so then we get climate change, and it's having quite an impact.
Yeah.
What kind of an impact? Can you give us some ideas there?
Yeah, one of the insidious things about climate change is it often is, we think of it as a trigger that fires the bullet. The way that the Pentagon thinks about this is that it's a threat multiplier. So oftentimes it's not, climate change is the cause, it's climate change interacting with something else. So it's climate change interacting with something like overfishing or interacting with development in the shoreline that's causing all this sediment to run in, or pollution stress. And so it's generally climate change is making bad things that much worse. And so just about anything you can think of that has kind of a negative impact has a climate change aspect to it. Now, that being said, climate change, we say that there are winners and losers. And so there are some species that are responding very positively to this. They oftentimes tend to be things we don't like. They tend to be things like mosquitoes and kudzu, and poison ivy loves temperature increases. But in some cases, they actually can increase the growth of some crop species. And so what we try to do is look at, even though this is going to hell in a handbasket, can we try to find some sort of bright side to this and capitalize on it as a way of adapting until we can find solutions to reducing greenhouse gas emissions.
One of the things you brought up, the interdependencies or the complicator factors, was the urbanization. And you mentioned a few things when we were talking a little while ago. First of all, the impact of urbanization on the sea coasts, and the other was the gates that would allow the salt water in and out. So I wanted to take that up to the marshes. But first, about this urbanization, we're all going to go under.
Well, hopefully not. That's,
not soon.
But that's what brought me to Boston, actually, is that at Northeastern we have this new Urban Coastal Sustainability Initiative, and it's a university-wide initiative. And it takes the view that we can learn a lot by looking at what may be pristine environments where the very few left on Earth, but realistically, there's almost no place, no corner of the Earth that isn't touched in some way by humans. So if we can understand not natural ecosystems as something that's separate from humans, but this what we call coupled human-natural ecosystem, that will provide a way forward to looking for solutions. So really, that's what we're focusing on is urbanization, but urbanization within the context of the natural environment. And right now, we often tend to think of those as very separate things. We have the ocean coming in with storms, and so we'll build seawalls to try to protect ourselves. But then those seawalls will cause problems that we don't foresee that we have to then go fix. And sometimes the solutions that we come up with create problems that are worse than what began. And you mentioned that the tide gates is a really good example where over 100 years ago, there were tide gates that were built between the ocean and a lot of the nearshore marshes. And the idea was that you've got these big gates that when a storm comes in, you close them, and it prevents stormwater from coming up into the marshes and flooding it. Well, over the years, they've either gotten stuck shut or people have stuck them shut so that they wouldn't have to deal with them. Well, guess what? Now, all of a sudden, you don't have all that salt water coming in. You don't have that natural flushing. You get a lot of fresh water building up. That changes the biodiversity, it changes its ability to support fisheries, but most importantly, it causes this invasive species of grass to come in called Phragmites. Well, it looks a lot like other grasses. You see it a lot as you're driving through Revere. I see it going into Boston.
Revere.
Revere. It's highly flammable. So unlike the natural grass, this stuff catches on fire in the blink of an eye. So you have a commuter rail going by where there may be a spark in the wheel, goes out in the marshes, and poof, it's a wildfire.
That's just amazing, because you don't think of grass, especially grass along a seacoast, as being flammable like that. But
my students went out there and they had to go through a preparedness drill where what happens if you have a fire, you have to basically cut a break around yourself, lie down, and hope for the best because it moves so quickly.
That's amazing. And where did this grass come from?
It's
I mean, is it a native grass and it's just...
It's found in fresh waters normally, but it's invading into these saltwater environments
because of
it's
this.
more, yeah.
Exactly,
Yeah.
exactly.
Yeah, so probably in its home range it wasn't causing a lot of damage, but it's someplace where it's not supposed to be.
Yeah, so our tampering with things that we had put up as protective devices and that showed an inclination to work with nature, to let that we have begun to alter, and we're in a little bit of trouble there. But we'll come back to this, you're working with community and so forth in just a minute. I'd like to ask you about the ways you do your investigations. You've had a number of very innovative approaches to the kinds of analyses you do, and you've developed a number of tools, I think. Can you tell us what do you measure? How do you do it?
Sure. So a lot of what my group does is called ecological forecasting. And it's this idea that rather than sitting around and waiting for climate change to have these negative effects that we know are going to happen, much like a disaster service or paramedics, can we triage? Can we figure out where the worst problems are likely to rise so that we know where to mobilize resources? We know where to start first, basically. So, for example, we're funded by NASA. We use satellite data. We use weather station data, buoy data from around the world. We put these into models that tell us something about how the environment, how weather drives the happiness and the reproduction and the survival of organisms. And then we turn that into metrics that are meaningful. So, for example, it might tell us something about the resilience of an ecosystem to change, or it might tell us something about the growth rate of a species that we care about because it's commercially important or ecologically important. So really it's going all the way from changes in weather to changes in the physiology and the health to what are the implications of that for society.
And you develop models and so on. Since we have some students in the audience tonight, can you tell us a little bit, because everybody does models, and they're pretty tricky, and I would like to know how it works.
So there are two types of models. We have these mathematical computer models, and then we have physical models. And my graduate advisor once said something very wise to me, that the model is a very explicit hypothesis that we go out and test. And so that's really what we do, is we take our understanding of how the system works. So again, we talk about climate change, but it's the phrase is that climate trains the weather, but weather throws the punches. And so really, that's what we experience. That's what an organism experiences. When we talk about climate, it's this long 30-year average. But how that's manifest is increases in extremes or longer number of days over some threshold. We can look at how that really drives heat in and out of organisms. We have this very biased view of the world because we're, as mammals, we make our own heat source. So we get too cold, we make some heat. We get too warm and we perspire and we cool. 99% of organisms on Earth aren't like that. They have heat that's driven by their environment. So it's driven by things like air temperature and the amount of sun they receive and even the wind blowing over their surfaces. We can keep track of that. We have very detailed models that we can test in the laboratory, and we've gotten really good at that. We've gotten good at taking satellite data and making predictions. Now, we also have to verify that, so that's our hypothesis. What we've done is we build these little robotic instruments that measure the world from, you can think of it as kind of a snail's eye view. So the way a snail or a mussel or an oyster or something like that sees the world is completely different than we humans do. So where a trouble spot is likely to be for something like an oyster is really hard to determine from our human bias. So we've got these little things that I think it was Discover Magazine started calling them robo-mussels. And so they record temperatures that are relevant to these animals. We have a new version that they talk to one another and will talk to a cell phone and will communicate information to the shore. And we have these things around the world now.
That's amazing.
It's really fun.
So what's their purpose in life? These little robos, do they measure the temperature of, say, the shellfish that they're assigned to or something.
Yeah.
This is way past drones.
Yeah, well, in some ways, yes. So we actually have people that are working on little robots. That
I should have asked.
No. I mean, underwater drones. But really, that's it. It's how do you measure a temperature? How do you measure a fever in an oyster or mussel using these instruments? And so one of the things, I think later we'll get to the international collaborations, but we've tried to find low-cost ways of doing this. So can we work with developing nations to provide them with this instrumentation so they can go out? We even use instruments that measure heartbeats in these animals. So our group has developed heartbeat sensors. It's like a fetal heart rate monitor, only for a snail, if you can imagine that, where it uses infrared and it measures using the Doppler effect the heartbeat.
But tell me, why is that important? I remember being really surprised when I was reading, your work, that there are temperature differences in the tides, and that organisms are quite sensitive to this, but there are temperature differences that we would find very difficult to adjust to, actually. Is that correct?
Yeah, absolutely is. And
that's why you have these little
so we get a fever of a couple degrees, and if that lasts for a couple days, we really start getting worried. I mean, one of my daughters used to spike a fever of 104, and we put her in the bathtub because it would really be worse. These are animals that have temperatures that can fluctuate by 30, 40 degrees in a single day sometimes. And so the analogy I use is imagine that you're kind of sitting on a beach in the Caribbean, and you've got a drink in your hand, and you're in a bathing suit, and then all of a sudden you're plunged underwater in Antarctica, where you have to hold your breath, and you have to stay in that cold water for the next 6 hours.
Until
then the cycle reverses, and then you go back again. And so really, I mean, that's why we look at intertidal organisms, those organisms between the high and low tides, because they are in some of it, they're used to this, right? They've evolved. The marine organisms have evolved, but they're already living right at their limits. So if they're able to contend with these wide temperature fluctuations, but probably not a lot more, and so that's where we're starting to see some of the initial die-offs.
Well, on that, I think you discovered or brought to the attention of the public that, in fact, you think, well, I'll just monitor the temperature here in the warm water. That seems like it's logical, but in fact, there were temperature spikes farther north. Is that correct? It was unexpected somehow.
Yeah, that's why NASA was interested in our work, is that they want to use NASA instrumentation to look at problem spots worldwide. And it's really, the only way we're going to do this is through things like satellites. But if you just take the world from the eyes of a human by measuring something like air temperature, water temperature, you miss that very local level. And so in this case, what we found is that in Southern California, for example, where it gets pretty hot, pretty darn hot, it happens to be that when the low tides occur in summer, the really good low tides are all happening in the middle of the night or early morning. So when it really gets hot, they're all underwater. If you look someplace like Oregon or northern Washington, all the good summertime low tides are happening right in the middle of the day. And so it turns out that there are places in Washington where the animals are much more stressed than they are much further south. And the tides move forward each day by 50 minutes, but they also get shorter and shorter. And so if there are 2 low tides a day, the low tide switches place with high low tide. So it ends up with this really complex situation where you end up with this kind of mosaic of temperatures where it can be as bad in the north as it is in the south.
That's just quite surprising, at least it is to me.
Yeah, it is. And we're finding more and more in other environments that these kind of local factors can partially override these signals we're seeing in climate. And so again, if we want to solve climate change, it's, the phrase we use is all climate change is local.
Which is very interesting, because you're right. We do think global anymore. Everything we're given is global averages, as you said, but you've turned the attention to local. Does that influence your international connection work, working with these different countries, because their conditions might be quite distinct?
Yeah, in 2 ways. So it broadens our perspective because we get to look not, in this case, temperature is one of the major places things is changing. Salinity is changing a lot in China. The water flow to the Yangtze River is changing a lot, and so I work with collaborators on the coast of China where we're looking at not just temperature but salinity. Ocean pH is changing in other places. So getting all these different combinations of stressors amongst different species that have evolved in different ways is really important. But the other side of that is that there are people around the world finding solutions to these. And so a lot of what we try to do is say, well, how can we put our heads together to look at our own local scale, but capitalize on all the solutions that people around the world have already started to do.
But do you see this as ultimately it is going to be local solutions, and somehow you put this together in a kind of mosaic, but that people will have to take these things on, learn how to do it on a local level, solve your salinity problem and stuff?
Yeah, so just to clarify, there are kind of two levels of climate change. One that we talk about is mitigation, and that's cutting down on the root cause of greenhouse gas emissions. And that truly is a global problem because you put something in the air and it affects
everything,
the globe, everywhere.
Yes, right.
But the other side is that we're committed to change. I mean, there's no question that even if we could cut off all greenhouse gas emissions right now, we are committed to some warming. So it's no longer a question of if it's going to change, it's how much.
No Band-Aid is going to keep it out of the way forever.
Yeah, I mean, the big challenge now is keeping it from hitting some really major tipping point. But the solutions often are local. So it's how do we, for example, if there's a population that we know is very stressed, if we over-harvest that population is that much more likely to crash, or if we allow development to occur at a location where they're already stressed due to temperature, that will send them over the edge. So it's, again, this kind of triage idea that if you find a place that the animals might make it if you just give them a little bit of help, that prioritizes that type of research. There are other places where they may be doing just fine. That may be a place you want to protect, so it can serve as kind of a seed source. And frankly, there may be some that get the black toe tag that there's nothing we can do. And if we try to save them, it'll be throwing good money after bad because they've gone so far over the edge that we're not going to be able to.
You mentioned that, working with people in Borneo, in Iraq, a lot of places that we don't hear about in this kind of science every day. Can you give us some examples of the kinds of things that you have discovered that people are up against in some of these different cultures? Yeah,
it's funny you mentioned Iraq. I mean, that's, if you can imagine the challenges we have studying climate change and then add all the insanity that's going on in the Middle East right now.
Exactly.
Yet I still have colleagues at the University of Basra who are trying to look at biodiversity. They're trying to get on with their lives. And so we've been working closely with them to look at how changes in temperature and water flow are affecting species moving up into the Hamar Marshes. This is the area that's thought to be where the Garden of Eden was.
Exactly, exactly. It's a very famous area. So this is endangered now?
Absolutely. In fact, it's already 90% of it is gone. And with increased damming of the Tigris and Euphrates, there's even less water flow. They join to form the Shatt al-Arab, which flows into the Persian Gulf. So there's a huge salt wedge that's moving up into Basra, and we think the marine species are starting to follow them on up. And so trying to figure out what's going on in that part of the world has been a real challenge. And again, the role of the group that I'm involved in is trying to help the scientists there to do the research. What they can do with what they've got at the moment, which is pretty meager, I'm sure, but in spite of that. And I mean, that brings up another interesting point. I mentioned the military before. You're probably aware that for the last couple of years, I mean, for quite a while now, the Department of Defense has issued, it's called the Quadrennial Defense Report, and yet again this year, climate change was listed right up there with terrorism as a number one threat. They view it as this threat multiplier for a couple of reasons. If you're the Navy, you have an awful lot of areas that are threatened by sea level rise. That's true. And your operations are threatened. It is thought to be a threat multiplier for civil unrest as well. I mean, it makes sense. If people are hungry, if people don't have access to resources, and they're already in a politically oppressed environment, climate change may be what sends them over the edge. And again, no one's saying that climate change is responsible for brutal dictator, but it may be that final push, that final straw.
Sure, it's going to make destabilize over a large. Are other militaries from other nations also concerned like this?
That's a good question. I don't know.
I know ours gets into everything, but of course they have bases all over the place. It's interesting that we can get the military to think about it, and if you will forgive me, a lot of politicians will not think about it.
The military gets it.
Isn't that
really
interesting?
Get it. Yeah. I mean, they're committed to reducing fuel usage. They're committing to reducing greenhouse gas emissions. Yeah, they get it.
Well, who knew? That's interesting news, I'll say. Yeah. I'd like to ask about your extensive work with education, that you have been very committed to engaging teachers, if you'll explain how you do that, and students and so forth. Where did it come from? How did you get involved in this, and what's your story about it?
Yeah, it's a pretty simple reason why I got involved is I have 2 young kids. So
there you are.
I have a 5-year-old daughter, Molly, and 13-year-old Morgan. And I've worked with their teachers as they were growing up. And this expanded into larger and larger scale programs where you realize that if you're only talking to other scientists in literature, you may be making an impact in the field, but really, if you want to have an impact in society, it's starting with that generation. I mean, they're the ones that are really going to feel climate change.
Yeah, true.
And so it's helping to prepare them for what's coming, helping them to face these challenges and find solutions is absolutely key. So we've taken teachers to the field a lot with us, where they've done research. We regularly go into classrooms. Right now, one of the things we're working on with other colleagues is developing video games that ironically actually will hopefully get kids to want to get out in the field more. So how do we certainly not replace going out and experiencing the field, but how do you augment that experience? I had the opportunity to work with Jacques Cousteau's grandson, Fabian Cousteau, on Mission 31.
Is that Mission 30?
Mission 31. Yeah, it was absolutely amazing because we were able to reach this huge number of people. I think the last estimate was over 500 million people.
Isn't that
were
something?
Contacted with this. And like so many other marine biologists my age, I know, I was inspired by Jacques Cousteau.
Yes,
and so to be able to work with the Cousteau family, we work with so many kids and to see the excitement on their faces. And we broadcast a lot of this back to Boston, the Museum of Science.
The Museum of Science, okay.
Yep. And so we're working with them to figure out how do we continue that? We developed a lot of underwater virtual tours while we were down there, and we're doing that now in the hot.
Did you tell me that you are going to be doing some more of this with the Museum of Science? Because we have students here, they may be interested in this. You were going to do some underwater filming or something
we're talking to them right now. Yeah. So there's nothing firm planned, but it's this idea that we take out a series of 6 cameras and put them underwater. And if you can imagine in this room looking all around you, and it would be as if you were underwater.
Yeah.
And lately we've started playing around with virtual reality glasses, this Oculus Rift, where you can put on a set of glasses and look around you, and it will be as if you're underwater. So imagine that on a planetarium.
I think it would be very exciting. Yes, absolutely. It just reminds me that your area is probably a productive one for like citizen science, that people can get involved in it. Do you do that also through your lab, or?
Yeah, we're just starting to do that because I feel like I've been drinking from a fire hose ever since I moved to Boston. There's so much going on here. But again, we've colleagues at the New England Aquarium and the Museum of Science Boston who do a lot of that, and so we've been partnering with them. And citizen science is a great way to get out after you have a storm event or something where you want to see what the damage is. And it's also a great way just to get simple baseline data.
Yes, I bet it is.
Yeah, I mean, in a lot of cases we have no idea what normal is. And so and again, what's normal now isn't normal what was 25 years ago. And so one of the things I love to do is go back through people's photo records and get stories. I live in Marblehead, and there are families that have lived there for generations.
Absolutely.
And to hear this kind of intergenerational conversation about what was normal 50, 60, 75 years ago compared to now is fascinating and also very scary.
Yes, it is. I bet you, especially for beautiful kingdoms on the seashore like that, really, where people thought they would live there forever, generation after generation.
Right.
That was the whole idea.
Right.
How, since it is a local thing, can you tell us what's the situation there? What about Marblehead?
So far there hasn't been any kind of systematic survey. It's all kind of anecdotal. But, you know, for example, the father of one of my daughter's friends has been going to the same beach since he was a kid, and he's just started seeing species there that he's never seen before. He found an octopus on the beach.
An octopus? My goodness.
Yeah. And it's stories like that I love to put together, but it's in some cases it's hard to see the change because this idea of shifting baselines, that what we perceive as normal is what we've seen in the past 5 years.
Yeah, right.
And so until you've actually put together what was normal 50 years ago till today, and there are a couple places around the world where we have that, where we have ongoing surveys, but you bring up the question. I mean, this is what's challenging, is that, you know, I can go to Marblehead and I've lived there for 2 years, but I can't tell you what's new because I don't know what it was like 50 years ago until I talk to somebody who can really tell me that.
Yeah, I can imagine this is a very rich area for a different kind of research that would help scientists tremendously by gathering these records, anecdotal and otherwise.
Absolutely, and this isn't specific to Marblehead, but a great source has been local fishers. So just today,
who are really
threatened. At a graduate student's presentation, and her father's a fisher, and she went to graduate school because of the changes she's been seeing. And so she works with fishers who tell you what they've been catching, where they've been catching it, the depth they've been catching it, and that's a tremendous record that really tells us about what's been going on. So again, that's a great resource that's well outside the scientific community, but they're the ones on the water every day.
It's amazing how scientific they were in a way, but of course it was very important, I suppose, for fishers to keep records. Is that the case? Did they keep them over years? Is that what you're telling me?
Yeah, in a lot of cases they do have pretty good records. We can look at landings, we can look at catch per unit efforts, we can look at how much they brought in and how long did it see to get that.
Right.
Is one example, and then we can couple that with these long-term records.
Right.
One of my colleagues who I work with in the UK, you mentioned I was in Plymouth, they run a monitoring program from Scotland to France and have done so at that institution for over 80 years now. And so they can see all these changes that are sometimes hard to see from one year to the next.
But generations are...
Yeah. And I mean, there was a cold winter in 1963, and they're still seeing the impacts of that. So it's tough, and I think this is part of our issue with communicating these changes, because it is very complex, and you need to look at a large-scale view, even though it's on a very local level that it's impacting you. So in order to get the answer, you can't just look at your backyard. You have to have everybody else look at their own backyards and then make that comparison.
Exactly. As a parting shot, then tell us, as a general public, how can we develop a knowledge of this best? Because, as you say, this is extremely complex, and there's also a time factor. You can't look at this week versus last week. You need to have a stretch of time and so on, and it's multidimensional. It's very demanding. Is there an easy way? Are there 10 quick steps?
No easy way.
Well, we failed that one, okay.
Well, but I think there are a couple things we can do. And one of the big things is having a sense of place, knowing what your own environment is like, and I think a lot of that is just getting kids out to the seashore and having a sense
maybe
of
some adults, yes, right.
Exactly.
Right.
But then also looking at, realizing that every place is somebody's backyard, and starting to have the realization that, you know, we're part of this global society, and climate change and other impacts plays out on a local level, but we're part of this really big puzzle piece. And I think anything we can do to facilitate those kind of discussions, and discussions from people from wide sections of society, because these solutions have to come from politicians, from engineers, from scientists, from educators, you name it. From
and there needs to be a good public sort of pressure for paying attention to it and letting you do your work and along these lines. Well, I hope that we will measure up as a general public, and I will stop here to let you talk. We have some students in the audience tonight, and I know that they will want to talk with you, and I will step aside, but I really thank you very much for giving us all this great information.
Thank you very much.
So much.
So you talked about a little bit about misconceptions about climate change. Where can I find some credible information about climate change denial?
That's a great question. There's a really neat study that's been going on for a couple of years by Yale and George Mason University that looks at the different kind of categories of people in the U.S. And there's a spectrum that goes all the way from people who understand that climate change is real and that it's really a pressing danger, to those who, no matter what you tell them, are just simply not going to buy into it. And there's kind of that middle ground where people are still open to ideas. And so what makes somebody in one of those categories or another one depends on so many things. Unfortunately, lately it seems to be really linked to political affiliation, which is really unfortunate, because it really wasn't that long ago that Republicans were leading the charge on climate change. In some cases it is linked to religious affiliation, but again, there's a lot of diversity in that. There's a large caring for creation movement. So in terms of understanding where people are coming from, that's a great place to start. In terms of kind of getting the real scoop on what information is accurate and what's not, there are a couple of good websites. There's one called realclimate.org that I recommend, where it looks at a lot of these kind of common statements that are made that, well, climate has been changing naturally for the last million years, and this is just a natural cycle. It points out that, yes, that's true, but normally the changes we're seeing the past 100 years take about 20,000 years. And so that's the issue, is that a lot of these statements on the surface seem like they make a lot of sense, but in a lot of cases they're just partial truths. And so when you look at where those are coming from the real scientific literature and how they've been kind of twisted, it gives you some sense of where we're at. Yeah.
Okay, I'm curious about a couple things. One is climate treaties that were going on in Peru, I believe, or Chile, just recently, Lima, Peru. And also, I'm curious about how things went, because they're trying to have all the countries involved instead of the major players, which I think is more sensible. Also, I'm curious about oil drilling and how U.S. is handling that. And lastly, I was just at the aquarium recently, and I saw clams or mussels or oysters are good for cleaning up the water. I wanted to hear more about that.
Sure. Okay, so your first question is about climate treaties and where we're at, and the second was about where we're at with drilling in the U.S. So up to this point, a lot of the climate talks have been very disappointing. And the central issue is that the problem has been caused by developed nations. And so essentially what we're asking developing nations to do is not enjoy a lot of the benefits that we've had from fossil fuels. I mean, let's be honest. I mean, fossil fuels have done a lot for us. I mean, we've got electricity. It increases transportation. So it's not that fossil fuels are evil. It's just that we're at a level that we can't support it anymore, that they're putting so much stuff in the atmosphere. So getting at that discussion about how do we find a solution that's equitable, that allows development in places like India is been a major sticking point. So recently, I mean, this agreement with China, the details are still coming out, but China is one of the major players right now. So for the U.S. and the China to come to agreement, I find is very encouraging. I mean, even if the details aren't hammered out yet, the fact that there's an open dialogue that's moving forward, I found very encouraging. In terms of drilling in the U.S., I'm sure you've heard of the Keystone XL pipeline, which is actually Canadian shale oil. The problem and why that's been such a focus is it's a really dirty source of fuel, and so it's pretty emblematic of the problem is that are we really serious about trying to find solutions? Because if we are going to prevent these tipping points, we're going to have to leave oil on the ground. I mean, the estimates are anywhere from 50 to 75% or more of what's left in the ground we have to leave there. That does not sit well with fossil fuel companies. What I find really fascinating is that countries like Saudi Arabia are seriously looking at alternative energy right now. So they see, they're certainly not stopping drilling either, but I think they see in the long run that this is where things are going to go. And so I try to stay hopeful that we'll get there. And then your final question was about mussels and oysters serving. So we call those things ecosystem engineers because they kind of like beavers, they change their environment a lot. So they do everything from stabilizing shorelines, they prevent erosion, to removing huge amounts of nutrients. I mean, earlier we were talking about all this stuff in the water column. They can basically vacuum clean it out. So it's like a filter in your fish tank. They remove a lot of that stuff. In places where there aren't other contaminants, that's a good food source. The problem is they also take up heavy metals. And I mentioned my colleague, Loretta Fernandez, who looks at that. So they're potentially a great natural source of doing a lot of things that right now we rely on concrete and really expensive filtration systems for. Does that answer your question?
Yeah.
Okay, great.
I could have modified one a little bit, but ocean drilling.
Ocean drilling.
Yes.
Somebody else.
Yeah.
Well, I'm an old student, so I wanted to ask you a couple of questions. You said you were talking about Phragmites, and I had heard that goats love Phragmites, and that might be a possible solution to the Phragmites in the wetlands. And the other thing is, and my second question is, you said that you work with Revere. Do you work with other communities in the greater Boston area? I live in Quincy. We have 27 miles of coastline. We have lots of marshland and a lot of it dead. And so we would love to be in contact with you.
Absolutely. And so the goats, cool. I hadn't heard that. I mean, in other parts of the world, goats create other problems too. So you probably want to tread a little carefully before we cut goats loose on 1A. But it's, those kind of natural controls are worth looking into. Right now, we're looking at the area in Revere as a case study, and so absolutely, we really want to work with local communities throughout the region, and so that'd be great. We'd love to work with you.
So I know you talked about how fishermen are really like a key factor in this because they are the ones out on the water every day.
Yeah.
Are you working with like a specific group of fishermen from a certain area, or just getting records from fishermen all over the place? Yeah,
so a colleague of mine, John Grabowski, has worked a lot with fishers in Gloucester. So he works with the groundfish fishery, he works with cod fishers up there, and with lobster fishers. A number of my students have started going and sitting in some meetings. And so my lab group is new enough to this area that we can't just kind of barge in. And so we're still at the stage where we're getting to know people, and a lot of this is just establishing mutual respect and trust. And so in terms of groups, we tend to work with people who have connections to a number of other people in the region. So growers, shellfish growers associations, or fishing associations. So we'll talk to anybody that wants to talk to us, really.
Okay. Thank you.
Yeah.
Oh, so I'm in the environmental club in our school, and I was wondering, like, what kind of actions, like, you would suggest for students to take action so like we can like kind of prevent like kind of climate change, or like kind of at least like take action, because like a lot of the ways that you suggested were for like government or like kind of like big system. And I was wondering like if there are any other ways that like clubs at schools can do, or like any other ways.
Yeah, it's a great question about how can you work locally to solve a global problem. And I mean, it's not going to surprise anybody here that at a federal level it's just shut down. Nobody talks to anybody else. So really, I think a lot of the hope right now is at the community and city and state level. And thankfully, we've got a lot going on here in Massachusetts. I mean, so there are a lot of action committees. I would suggest the first thing is just figure out what other groups have stuff going on in the area, and see if you can team up with them. It's great to start something on your own, but if you can build on other connections and solutions that other people are exploring, I think that's a great way to start. I had a group of students that started building community gardens and in the Boston area, and that was building on an existing program. A lot of it is just raising awareness and talking to people about the changes that they're seeing in their environment. So I think, again, it's going to be tailored to exactly where you are, but I think just start talking to people, find out what the major problems are.
By all means, Dr. Helmuth, thank you ever so much.
Thanks. And my email address and phone number are there as well. Feel free to contact me about anything, or if you're at Nahant, come visit.